Got a 2013 Chevy Suburban. It's a 5.3. It's got some fuel trim problems. I'm gonna show you that. It did have a check engine light for the fuel trims, but I wound up clearing those because there was an obvious vacuum leak. The purge valve somehow got disconnected, but once I reconnected, reset the fuel trims, they started going extreme. Right now, it's at negative 13 and 9, but they went up to negative 18 and 21. Let's go to mass air right here and do a conversion. I need to get those other ones. Here we go. Convert those over. So currently right now it has 5.6 grams. I'm going to let it sit there and do its thing. Maybe it'll change and go back up to, I want to say, negative 18. Let me look at the graph here. Well, we can just look at the numbers. I mean, they are fluctuating. See that there. So it's dropping 5.8, 6.2. When it was pegged out, it was around, I want to say it was around 5.8 grams. So there you go. There you go. Now it jumped up to 5.8. It's cool. We can capture that. You can hear the engine change too. So they're pegged out. I'm going to rev the engine up, see if it changes. It shouldn't. Kind of went through a check already. Now it's dropping again. But let's see what happens. Speed up my filling the truck. It's still pegged out. I'm going to assume that it didn't change because before when I was checking it, it didn't change. So being that we see some fluctuation, and let's go to the short term, see if it went negative. I'm sorry, positive. Yeah. Nope. So what'll happen naturally, they'll make accommodations, and the long term will hold those accommodations. Now, being that both banks are affected, I'm not going to think of oxygen sensors. It's just pointless. Don't chase your ass. The mass airflow sensor is going to be the massive overall change. So let's pull that out. I used a T15. I want to say, I swear this was a T15. Got this, pulled the screws out, fasteners or what you call them, and observe the mass airflow sensor. See what that looks like. This is the opposite side here that don't see the filtered air. This is the portion that gets the filtered air. You see how dirty that is. Those resistors get hot, and once air flows through there, it changes value because it's the temperature. So once these thermistors or resistors change temperature, it changed the voltage going through them. The PCM sees that value, and the engineers were nice enough to give us a calculation and an interpretation of what we are accustomed to dealing with. Not that Celsius crap, but Fahrenheit. So this is what we're dealing with. What we're gonna do, we're gonna clean it first, see what happens, because it's obvious. I mean, it's just distorted. If it's distorted, can't get a good reading. It's the same as holding something in front of your hand, blowing it. You're not gonna get a good measurement of how that temperature is coming out your mouth, that breath. So same thing with this. Let's get some brake cleaner. So I have it in my hand here. I'm gonna take it and I'm gonna shoot it clean and take some compressed air, blow right through it, pop it back in there, see if the values change. Now I'm not gonna reset the fuel trims just yet. Once I get it back in there, I'm gonna see if it'll naturally do it on its own. because then we'll see if it made a change or not. So here's the after. It looks a lot better. It definitely doesn't look the same as before. There's the other side. I'm not gonna worry about that. All right, let's pop it back in here and see if we got some change in the field trims. Our number should drop. The higher the number, the richer it is. It's going to indicate. Our number should be, well, the rule of thumb is the displacement. So it's a 5.3. It should have been 5.3 around 500 RPM. So I would imagine the numbers that it had was proper, but I don't know. It's general rule of thumb. Maybe we did see the lower the number, 5.3, the more moderate the field trims were. When it went up, then it went rich. But the RPM definitely should have been playing a factor here. Anyway, again, that's the general rule of thumb. So it's 5.3, should be 5.3 grams per second at 500 RPM. So you kind of do the math. Let's start it up. Those numbers did reduce, but it's still like dancing around, so it's not stable. I wouldn't be surprised if just the mass, I mean, this is an old vehicle. I wouldn't surprise me if the mass afro sensors just need to be replaced, but they are definitely a lot lower. Also, it could be the temperature because of the cold brake cleaner getting on that sensor. It needs to warm up. So we'll give it a minute. Dropping a little bit. That's a lot better. So our numbers, I would imagine our short-term field trim should go positive. No, look at that. It didn't. So being that we got the calculated flow to drop, well, let me do a reset of the field trims and see what happened. I'll go to special functions here. Field trim reset. The short term is still going negative. Don't really like that too much. Let's take a look at the O2 sensors. So yeah, even after the reset, our field trim still went extreme here. I guess it's worth looking at the oxygen sensors, but I'm just for a minute, I just don't think anything's going to come about. So assuming our oxygen sensors are the problem, when I do a reset, I'd imagine they would go rich. On oxygen sensors, the lower the value, the leaner it is, the higher the value, the richer it is. They're the inverse of Alfvén ratio sensor. So we're going to look at bank 1, sensor 1, bank 2, sensor 1. Yeah, so everything went rich. So what that means, I'm not going to focus on the oxygen sensors because all of them are reflecting a global issue, which is going to still wind up pointing to this mass airflow sensor here. because at some point, once the oxygen sensors change, they do wind up oscillating like they're supposed to. Could it be fuel pressure? It could be, but I doubt it. I'm not going to sit there and say it is in this particular case because it's not exactly pegged out. These are just, let me see if I can rev it up. So it still went negative. Yeah, I think we just need to put a brand new mass airflow sensor in here. Let's go back here. Let's go to fuel trim. Fuel trim, let's go to, I'm still in special function here. Let's go to fuel trim. We could see what the options are with the fuel system. As a matter of fact, let's go back. Let's look at there, and they might have oil fuel pressure. The desired versus actual. The fuel alcohol content. I'm not sure if that had anything to do with it. I mean, that is a little high, but I'd imagine that'll make it leaner, not rich. So we got fuel pressure. I don't know if this has a fuel pressure sensor or not. It don't. Okay. Let's see if I got something. Fuel trim enable, fuel composition reset. Let me just try this. See if it made any difference. Because it probably seen that, and then it wanted to make accommodations based off the alcohol content. Let's see if that changed anything. So that was better, being that I revved it up. It didn't hold that negative 18, but let's see how it responds at idle. I mean, as long as it's below negative 15, I think it's making some change. Let's go back to, I did not mean to go there. I don't even know where I went. Fuel composition reset. So with the fuel trim enable, oil life. Let's go back here. Let's see if it went back up or stayed the same. So it's at 3%. So it needs to be below 10, I'd imagine. I mean, that's what the alcohol content typically is. Yeah, let me give it about, what time is it now? How long's it been running? Give it about 3 minutes, and we'll see if anything changed. Or either just another minute, because before it didn't take that long to get pegged out. I'm actually a lot more satisfied with this than the 18. I know with the Hyundai, if it goes above 16, then it'll create a code, or like negative 16 or positive 16 or something like that. It'll generate a code. I'm not sure about Chevy, but typically with most vehicles, you want to be below 10, closest to 1. So this is definitely, let's go back to our mass airflow sensor in the meantime and see if that made any difference. I don't know why. That's right, because I was in that. Let's go to fuel trim. So fuel trim. So we're still -13. I feel a lot better about those values not being pegged out and not responding when I give it throttle. Let's go to our mass airflow sensor. There we go. Let's see how stable that is. So it's still low. It's not about 5.8 like it was before. Let's give it another throttle. Because like I said, those mass airflow sensors look fine. I mean, it obviously was dirty. Obviously was. Let's pull up short-term fuel trim. So it's holding that when I give it throttle. Let me take it on a drive and see if it adapts. Just got back off the test drive. I'm satisfied with the numbers. They're below 10. And at one point they did kind of push up like 12 and 15, but they went immediately back down to 8 and 10. Let's see if there's any check engine light codes. And y'all wound up seeing what the values were while driving. That's not a concern. I mean, they went 0, which is great. So no codes present. I think we're fixed. Mass airflow sensors not high as it was. Gets cleaned up. The fuel trims are decent, and it'd be better if it was at 0, but they're around 10, so they're fine. We're good. No parts required. Hey, look, if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed. Had a rich some work. See you on the next one.